When we hear about life on other planets, we often imagine creatures like those we see in movies, green-skinned aliens with antennae and pointy ears. But what if that's not the case? What if there's life out there that looks nothing like us? What if it's not even carbon-based? That's exactly the question scientists are asking when it comes to Titan, one of Saturn's moons, and our best chance yet at finding alien life elsewhere in the universe. Join us to see this incredible astronomical data that has all the experts in ecstasy. This is Interspace. Titan is a moon of Saturn and the only moon in the solar system to have a substantial atmosphere. It was discovered by Christian Huygens in 1655, but its existence was not widely accepted until Giovanni Domenico Cassini confirmed it after his own observations in 1671. Titan has been well studied since then, and its surface has been explored by several landers from NASA's Cassini probe. Titan's atmosphere is very similar to the atmosphere of the Earth before the evolution of life. Titan has a nitrogen-rich atmosphere with a small amount of methane and other hydrocarbons. The ratio between these two components is about 1 to 1 million compared to air on Earth, where nitrogen accounts for 78% by volume. Titan's atmospheric pressure at its surface is about 1.5 times that of Earth, although it decreases with altitude from 0.6 bars at sea level down to around 0.2 bars at an altitude of 50 kilometers, 31 miles. The search for life beyond Earth is having a moment. NASA has made it one of its top priorities, with plans to send an orbiter and a lander to Europa in 2022 and multiple missions in the works to visit Mars moons. Meanwhile, private companies like SpaceX are also interested. They're planning on sending their spacecrafts there as soon as next year. But what if we don't have to go all the way out into space? What if we can find life right here on Titan? Titan is the largest moon of Saturn. It's bigger than the planet Mercury, and its thick atmosphere makes it one of the most promising places in our solar system to search for life. Scientists know that Titan has lakes and seas of liquid hydrocarbons, such as methane, but they haven't yet determined whether these are produced by geologic processes or biological ones. Titan's average surface temperature is -180 degrees Celsius, -292 degrees Fahrenheit, which means it would be too cold for any Earth-based microorganisms we know about today. But there are plenty of organisms on Earth that can survive at such low temperatures, like certain types of bacteria found in deep Antarctic ice cores. The Cassini-Huygens mission was a joint project between NASA and the European Space Agency, ESA. The two agencies shared costs and responsibilities for the unmanned spacecraft, which was named after Italian astronomer Giovanni Cassini. ESA provided Huygens, an atmospheric probe that was released from Cassini to study Titan's atmosphere. NASA provided both the main space probe and its Saturn orbiter. NASA launched Cassini-Huygens from Cape Canaveral Air Force Station on October 15, 1997, a Tuesday. It reached Saturn after 6 years of travel through the solar system. Both parts of the spacecraft separated from each other at that point so they could reach their own destinations. One part continued toward Titan while another descended into Saturn's atmosphere where it would eventually crash land there, or rather. Cassini was the fourth spacecraft to visit Saturn, following Voyager 1, 1980, Voyager 2, 1981, and Pioneer 11, 1979. Cassini's primary mission ended in 2008 when its orbit decayed, but it continued on the extended grand finale phase until 2017. The Cassini spacecraft sent back images of the moon's surface that showed what looked like lakes, rivers, and deltas. By analyzing one of these hydrocarbon lakes, they found evidence of methanogenesis, which is a chemical process that produces methane gas from other carbon-based molecules. This could mean there are microbial organisms living in those bodies of liquid on Titan and feeding off those processes, or perhaps there are non-living organic compounds that have turned into living things because of their environment. Cassini also uses radar to explore Titan's surface. The radar sends out a pulse of microwave energy, then receives the reflected signal and analyzes it to determine how long it took to travel. Scientists use this information in conjunction with their knowledge of the reflectivity of Titan's surface and its atmospheric composition to determine what type of material made up that spot on the ground or in the atmosphere. Cassini cannot distinguish between materials that make up different types of life forms. However, it can investigate whether there is evidence for complex organic molecules such as amino acids or nucleic acids, DNA, RNA, on Titan's surface. Some scientists believe these are necessary building blocks for life as we know it here on Earth. If they exist at all outside our planet, They might be present on other planets throughout our solar system, which could mean that some form of extraterrestrial life exists beyond Earth's biosphere. A team of scientists from NASA's Jet Propulsion Laboratory, JPL, has proposed a mission that would send an autonomous drone to Titan, Saturn's largest moon, to search for life there. The proposal is currently under review by NASA. The spacecraft would launch in 2033 and arrive at Titan in 2038. Once it arrives, the drone will be able to fly at low altitudes, so it can sample Titan's air and surface. Titan has active volcanoes, oxygen, and nitrogen, all the elements it needs to support life. The surface of Titan is believed to be covered in liquid methane, which is similar to water on Earth. During a flyover of Saturn's moon by NASA's Cassini spacecraft in 2010, scientists saw evidence of hydrocarbon lakes and seas that could sustain life. And unlike Earth, Titan doesn't have plate tectonics or an atmosphere thick with carbon dioxide, two things that make our planet inhospitable for living organisms. Titan is one of the most promising places in our solar system to look for life beyond Earth. There's no place else like Titan, said Jonathan Lunin, director of Cornell University's Center for Radiophysics and Space Research, who leads the Tidal Evolution and Interior Structure (TICE) team on board Cassini. It's got liquid pools and rivers, it has rainstorms, it has dunes and mountains, it has complex chemistry, so much so that when we send humans there someday we'll need an astronaut biologist on board looking at these questions. In conclusion, the future of Titan is uncertain. If there is life there, we may never know it. But if someone finds something unusual on this moon, we'll know exactly where to point our telescopes. If you liked the video, give us a thumbs up and let us know what you thought about this fantastic discovery in the comment box. This was Interspace, see you in the next video.